Hello, in this video we are going to work through example 1 in section 6.1. And example 1 has asked us to evaluate the integral of x times e to the x dx. Now to evaluate this, we are going to use integration by parts. And specifically, we are going to let u equal x and dv equal e to the x dx. Don't worry just yet about why these two were chosen as they were. If you look at the lecture just following this, you will see some information about how that gets chosen. But for right now, just trust me that u is equal to x and dv equals e to the x dx is what we want here. Well, then we need to differentiate u, so we're going to get that du is equal to simply dx. We also need to integrate dv, so we're going to integrate dv. That means that we're going to integrate e to the x dx, and we know from Calculus 1 that the integral of e to the x is just simply e to the x. So we get that v is equal to e to the x. Just a quick note in case you haven't seen this double arrow notation before, it does mean implies. I will use it when I am working through information in this class to basically indicate that the next line follows from the previous one, so it's sort of like the next step. So what I have written here implies that v is equal to e to the x. So we have u is equal to x, dv is e to the x dx, du is dx, and v is e to the x. Now, our integration by parts formula says that the integral of u dv is equal to uv minus the integral of v du. So to apply that to the integral that we have in example 1, the integral of x e to the x dx, this is u, this is dv. So we have the left side of the integration by parts formula, so this must equal the right side. So we're going to have u times v. U is equal to x. V is equal to e to the x. So we have x times e to the x. Then we have minus the integral of v, which is e to the x, du, which is dx. And now we have this. Now we aren't quite done with evaluating this integral because of the fact that we still have an integral on the right-hand side. However, this integral that we have on the right-hand side is much simpler than what we started with. We know, we've already in fact evaluated this integral once in this problem, we know that this integral is equal to just e to the x. So that means that we have our integral of x e to the x dx is equal to this first term. We simply rewrite because that's already been integrated. Then we subtract and we evaluate the integral of e to the x dx to be just e to the x. This is an indefinite integral, so we do need to remember to add c. So our final answer then is the integral of x e to the x dx is equal to x e to the x minus e to the x plus c. And there is our answer for example 1.